Number 3B. I think some of you overthought this question a little bit. It was just asking you to write the appropriate form of Newton's second law for each object, like the two blocks and then the pulley. So for each block, so like part I, if I start with this block, the one that has a mass of m that's on the left here, it's going to move in a straight line. It's not going to rotate. So I'm just going to use regular Newton's second law. So net force equals ma. But then I'm going to write that specifically for that mass. So here are the two forces on it. We want to think about the direction that everything's going to accelerate so that we can call that our positive direction. So the heavier mass is on the right side. So we know the acceleration is going to be in this direction, basically. So if we're focusing on this mass first, it's going to accelerate upward. So we want to call that the positive direction. So like the upward force we will start with, and then we'll subtract the downward force. So net force on that one is T1 minus mg, and that will equal its mass, which is m, times its acceleration. Then for the other block, again, net force equals ma. So for this one, it's going to accelerate downward. So we're going to call the downward force the positive one. That'll be the stronger force for that one. And then we're going to subtract the upward tension, which is tension 2. And then that one, its mass is actually 2m times acceleration. I can use the same a because they're tied together with a string, they're going to have to accelerate at the same rate. So that is the same acceleration in both equations. So that's for each block. And then for the second part, they wanted the appropriate form of Newton's second law for the pulley. The pulley is going to rotate, so we're going to use the rotational version. Net torque equals I alpha. So the two forces creating torque on the pulley are the two tension forces opposing each other. Because it's going to accelerate this direction, the stronger one is where the heavier mass is, so T2 is the stronger. So we're going to have that one be positive. The torque created by that tension force, the tension force is kind of happening right here, downward. So the distance from where the force is happening to the pivot point is just r, the radius of the pulley. And torque is rf sine theta. So we would have r times T1. We don't need the sine theta because the force is perpendicular to the r vector. And then we're going to subtract the torque from the other tension force, which would just be r times that force, T2. So that's our net torque. And then that has to equal the rotational inertia of the pulley, which it told us was 3/2 mr squared times the angular acceleration of the pulley. So that is our equation for the pulley.